Hello everyone, I'm Abhinav Pandey, a cybersecurity enthusiast and a penetration tester. To get you all going, our next speaker for the day is N. Vishwas. He talks about hacking, deep learning, computer vision, machine learning, and artificial intelligence. Today, he'll be talking about testing and security for deep learning folks. So I hope you enjoy. Thank you.
Hey folks, this is me, Vishwas Narayan. I'm the speaker for this topic on testing and security for deep learning. Folks, trust me, when I came to engineering and I was fiddling around with a lot of things to learn, and deep learning was something which really caught me up and said, hey, this has life and this has a requirement for security as well. So that's where I reached out to a lot of researchers, and now I'm researching on the security aspects as well. So if you think of any of the things that I've been doing, I'm just a computer nerd who is more into the hardware, and I just love the computer vision. And this is where things like one pixel attack and everything comes up. And I'm a bibliophile. I read a lot of papers. I just love to understand the neural network, even though I have not learned anything. Like probably my knowledge is zero compared to somebody else who is probably researching exclusively on architecting such kind of a solution. So now if you can think of something like this, I'm saying you, there is a common vulnerability which is always exposed on our platforms. And it's not about, yeah, it's not about we building something which is cool as something like this. It's beyond it. It's from a paper which is bug bounty hunting and machine learning. How is it going to have some sort of an impact for our learning in the future? There are a lot of things which I cannot say because there is an hidden complexity in everything that we are talking about. There's an AI which can really go wrong. There is an ML which is always having some sort of an insight from the collected data set, which is analyzed, which is summarized through some or the other techniques. But common thing is there is data engineering required in AI as well as in the ML. And right now, when you think of some complex thoughts, this is what deep learning to me is. It's big data, predictive analysis, security, cognitive computing, natural language processing. Everything is involved today because we are now building something known as a precision medicine, which requires all of these. We are building something called as an AGI, artificial general intelligence, which requires all of these. And data models, processing power, and big data is what we really care about. And AI is an attempt to build a human intuitive intel, like something like you have some sort of an intuitive thought, right? Every time when you make some changes in your learning, you have some sort of an intuitive thought. And that is what you want to mimic here. That is what you want to say, like, hey, this is what I'm thinking about, and this is what I'll be working towards. And if you think of what is the rough estimate of what can happen, this is what things are. A data scientist has his favorite tools or wrappers, and there is version control and there is model management. On the other side, when you look at it, there's a developer who calls APIs and monetizes on the deployed model. And but always be a data scientist because that's an iterative process. You need to just jump in here and there and say that, hey, this is what my model building process is all about. So the agenda is neural network and testing in deep learning. And also, when I say about neural networks, I can't say it without saying what is the actual meaning of it. So a neural network is basically a biological history which just followed out, and in order to just give something, it's just a humble attempt that we had in order to build a burning box react as good as a neural network. And AI is something which is cool. And there is an approximated hardware, which is something like this. There's always an X amount of inputs, W will be the weights, which will be a summation, which will have some sort of a function. That function is called as an activation function. Don't worry, if you are very new to this, just follow my lectures out there on my YouTube channel, Vishwas Narayan. It will be there for you guys. And traditionally, this is what we did. A data and an algorithm and an output. But this was actually more secure than what we had in a neural network being taking place, all the things. Like if you think of the things today, it's data, outputs, and algorithm, but it doesn't end there. So there is always a data, outputs, and a model, and even more data, and there's a model, and there are some predictions which go on. So typically, this is what we think about. So it's all about that complex amount of inputs going in. There are some biases which moves in, and what next. So this is what we architect towards. And this is where you came to know that, hey, there's a control system which has a feedback loop. Let's just design a neural network with a feedback loop. This is known, but the way in which the neurons are behaving is not yet known. And if you think of some tools like Netron and all the things which are already available for you, there is already a rapid requirement which is already there. Netron is an amazing tool which helps you to get to know what's the neural network architecture. So there is a neural network, there's an activation function, and what's an hyperparameter? That's what we are thinking about for a neural network. To be very frank, this is one of the most crucial security parameters that we can look at any model today. So basically, there is a cross-validation which has a nature of data set, which is supposed to be simple or unique. And there's always a new way of understanding what is it all about. So there is always a testing and a training data set, which just keeps iterating over a course of time. And you will always think of like, hey, what should I do next about getting all the sorts of data set? And basically the training happens in a very iterative fashion, and probably fourfold validation is better for any person. But I would say just try out with fold 1, fold 2, fold 3 that is being shown here. Now, if you think of model evaluation, there is a huge set of parameters. There's regression models, there's band index, there's CV errors, there is precision recall, and all these are simple matrices which are really, really important. So AI can really adjust for all these, and you have to just get to know what's a regression square, what's actually happening when we are taking an algorithm, right? Ridge regression, lasso regression, linear regression. And bias in ML is very unique. Any ML model is biased towards the model that is trained on. Like often the data is biased, or else the parameters gets biased. It's important to know what do you know about the trained model, because it will affect the model tomorrow and says that your system is vulnerable for the tomorrow's world. So there are ways in which, but in my research, I've always been using something as a unit test, a test for the presence of the adversarial example, a test for the model performance and fakes, and many more. So adversarial examples, when we took into the consideration, there is something called as an adversarial attack. The codec is one of the best parameter that we could ever diagnose before we deploy the model, because codecs are always there in your Raspberry Pis, a DSP processor, an FPGA, and whatnot. And one pixel and many pixel attack is very common in computer vision, so it's not a big deal. So noisy information and noisy decoders, that's what we are always talking towards. And how are we just initiating an hardware-based approximation? And all these are basically one design approach. So a simple example from the one pixel attack adversarial networks is pandas and the noise gives rise to Gibbon. Gibbon is nowhere related to that, and Gibbon is just being told like this. And when we saw the code and we saw the way in which they have architected it, and this is a state of the art attack that can really happen on your neural network. So humans can get confused. There is a few things where it can be attacked on an optimization, and the companies have the right architecture. That's fine. If they have very wrong timing, that's the best curse that you can put on them. But the skewness is, how do you think like a brain? Like brain is somewhere down the line can also realize which is good, which is bad, but a model can never realize that. It's because it just deals with ones and zeros. So if you think of some advanced patterns, this is where we go towards, and this is where your self-driving car comes into the picture. That's also part of my research, where we are having a huge set of model where you just combining everything here. Of course, when you see the predictions, it still goes down and predicts some parameters which are very similar to what we see in cars, trucks, airplanes, and everything. So yes, they can be transferred from humans, just like how we have a contextual information, insights and insight, intents being poisoned, there will be toxic insights which will be covered. So hypothesis is that they can transfer to model and can target features that are relevant to the human visual system. Interfaces are smart and they can never be fooled if you have trained them properly. So if you think of some sort of black box attack, there are ways in which it can be taken care. It can be transferred through different architecture, different data, loss functions, and data biases and model biases. There is something called as model drift and data drift that can also start entering. It's basically not a problem statement from the technology perspective, but it's a problem statement from the business perspective. But how can we prevent it? We move the fetching clues perturbation scene more dominantly. That's what we are as humans, and reducing the gap between a model and a brain. That's what we are thinking about. So there's a world, there's an Homo sapiens who starts blurring, and there's a database which is brain, and it starts building out. And what we are now is trying to do is a non-equivalent approximation of what a brain can do. But the models are evolved over a period of time. They can generate an image that can be the presence of a pixel, that can fake the pixels actually, which can be like something like deep fakes, which can be used. But to be very frank, deep fakes are today used in security aspects. Like they can retrieve a model using GAN. So that's where they're using it. So model quantization can also be a very effective one. So I have been working on different data sets, JSON, CSV, XML, YAML, C, and there's different file format for the model, CKPT, H5, PMML, and so on. And project structure and CI/CD tools, and that's what we are thinking about. We are thinking about how can we do it with the Docker, but Docker has its own way of not giving access to root users. But sometimes if you don't configure it properly, it goes to the root users as well. So make the prediction, bring the accuracy, then work on the deployment. That's what we are always thinking towards. What's the difference? A graphics card and a graphics card. There is no difference in any of the things that we are talking today because it's all AI, it's all deep learning, whatnot. So if you want to really get to know what is this all about, so you can read this paper. This is a state-of-the-art paper that you can think about. And trust me, just move one on the testing. Like you have to know like what are all the different ways in which you are testing your models, and these are some of those, and these are going to help you in getting the right insights. Find bugs early, iterate faster, debug more easily, design better codes. This is what we think about. If you think of something called as a philosophy of software engineering, an amazing book, he talks about all these. So a really good investment is this: invest on test codes. Investing on test codes are just going to give you a lot of insights. And learning to write a good test code is a really good investment, as they are way more overwhelming initially, but they have their own ways of understanding what this model can also do. So pick a single specific functionality to verify, use the available tools to get anything else and a way out of it. Try doing something and let's just get digging, because that's what we always do, right? That's what we always architect towards. And to be very frank, let's just look at how we can look at a web scraping system which uses bots for the security, which is using AI underneath it, and everything is not being sorted. And if you think of something like, it didn't allow me to just get inside this URL easily because there was a bot which was already built. So what I had to do was I had to use soup, BS4, beautiful soup, and I started iterating towards, and I was expecting something else, but I got a bot. And this bot really, really shook me up, because There is always a DNS which is always attached to everything. But when you think of some sort of a new page and new page being told, and this is the JavaScript that is coming up, that's going to track you down and that's going to say you, hey, this is not going to work. If you think of any of these lands, it's a local area network. There is always a firewall between the wide area network. And this is what we are thinking about, where an AI can make a lot of changes. And if you think of advanced systems like Uber, Dream 11, and everything, they have their WAFs. WAFs have been designed, and there is a deep learning model that is always being deployed through a bot, and bot is taking care of everything. So I'll be sharing you all these resources. Don't worry about that. And everything about pandas, machine learning, deep learning is there in front of you. Right now, it's an amazing topic to discuss and whatnot. And if you think of something called as an info, you can think of there's a length of it, there's a t type of it, and you can think of how the plots have been also taken place into the consideration and so on. So it's one of the machine learning Python libraries that we can think about, and this is what we are architecting towards. We do not use all of these models in the production system, but yet we are having a good taste of it. So, when I talk about deployment, we always talk towards the edge deployment as well. So an AI can really give you a lot of insights towards anything and everything that you're talking today. So this is what we are talking about. So it's a very simple program. It's taking TensorFlow and it's taking the versions of it, and it's just training towards the fashion in this data set. And now I'm using a convolution neural network. To be very frank, this looks very overwhelming, but this is something which we don't even consider as well. Like, we need more parameters, we need more trainable parameters, and this is what we think about. And AI can actually think of all these, and we have already been architecting it towards. And if you think of a future version of it, this is what the deployment look like. And what we are now doing is we are using TensorFlow serving, and we are just architecting it towards. If you think of Google TensorFlow serving and Docker, if you just go here, there is always a TensorFlow serving, which is already there for you. Just get to know all these models. This is going to help you in all the other ways. And to be very precise, in the production system, what we do is we take a deployment through an Onyx model. Onyx is something which is huge. And this is an internal project from Microsoft. They maintain it extensively, and they have started to use a lot of these. And I've downloaded the model. You guys can download these models and start working on any of these, and everything works perfect for you. And there is a super resolution Onyx, which is already been there. So you guys can go out and check out what is happening here and whatnot. And everything is being there. So there's a torch vision module has been generated. And what you do is TF2 Onyx, and all these models are always being taken place into the consideration. And you are now converting an Onyx model, TensorFlow model to Onyx, and this is what we are working towards. And there are a lot of other ways in which we can start converting the model, and this is one of the ways in which we started architecting a model. And then we got some training parameters, and then we are updating all these models, and now we are converting all these model and getting the predictions here. And it's a very nominal way of getting what is this all about. And it's a tabby cat. It's not an Egyptian cat, it's a tabby cat, and it's all doing its work, and it's all taking all the models and converting it into a super resolution model. So that's it, folks. Do enjoy the series of webinars that's going to be there in the podcast, and thank you so much.
So thank you very much for that insightful session, Vishwas. We hope that our audience learned a lot, and thank you again. Have a great session ahead.